Today we have Gary Carr talking to us about Amazon Alexa. So go ahead and let's start.
Hello, I'm Gary Carr. I work for American Fidelity along with David Roberts, and I'm a software architect, developer, photographer, Dynatrace advocate, and an Alexa skill set developer, I guess you could say, since it's developing skills that we do on Alexa. What I'm going to demo today and show you today, you could do this same technology with Google, with Siri, any other technology that's got the vocal stuff that runs on an API backend. What I'm going to talk about today is Amazon Alexa, the Echo in specific, since that's what I have with me. But we'll talk about how Amazon uses their AVS system, where it runs, and then how to connect the back end to it. There's different ways you can do that. We'll go into all those details. So first of all, Amazon Alexa, did anybody watch any of the Super Bowl commercials this weekend? Right? Everybody see the Alexa commercials? Yeah? So that's not a reality. You can't take down the voice. You can take down, I guess, just like you could take down Google APIs, you could take down the Amazon AVS. But it was pretty cool watching, to see those commercials, knowing I was fixing to be up here talking about stuff. But Alexa uses the Alexa voice service, which is hosted on Amazon, which I don't know what you do or do not know about Amazon, but Amazon has what's called Lambda. It's a serverless scripting technology, you can write skills for Alexa using Lambda directly onto Amazon and AWS. Or what I've done, since we're a .NET shop, is I split our API outside and I actually wrote in native language that our developers can understand. And so the resources are available for anybody to pick up development and move forward with anything, versus the cooler, newer technology that everybody wants to go run and jump onto. You don't have as many resources available moving forward, unless you're a shop that's continually building and developing that. Most shops, it's hard to get newer technologies brought on board quickly. But AVS basically is just their specific code they wrote to do the translations, to convert voice into speech, and then to take the API, which is JSON data, and bring that back, and gives you the ability to mark it up. You can do it in a clear robotic type speech, which nobody wants to listen to, or you can mark it up, which is SMS. And that gives you the ability to add accents and fluctuations and pauses and everything, so it's more real. So it's not anything like talking to David when you talk to him. So what I have written is a insurance application. I work for an insurance company, so my app is just a demo of an insurance application. What some features are that you can use for it, and then that gets you kind of thinking. And once you see this in action and how well it interacts, you can pretty much do anything with it. I also wrote a joke skill set, which is easy. You put 20 jokes in a string array and just randomly go grab one, 4 lines of code, you got a Alexa skill set, and you're like, woohoo, you know. It's a little bit better than Hello World. It's, you know, tell me some jokes. But once you get the basis down for in .NET, how the controllers are set up and how that JSON response looks like, you can do anything you want. Of course, you do not have to write it in .NET. You can write it in Lambda, and then you can stay all on AWS, but mine is actually hosted in Azure, so the API. So I'm using both clouds, multi-cloud, for this stuff. So in our situation, we have Alexa owner who owns the device. Now the device can be, as I showed earlier, Spot, Dot, Echo, Show, any of those devices, or any of the new devices they come out with, which includes Fire TV, your cell phone, your cars, any of that stuff that can interact with it. In our case, the policyholder, which is our customer, would speak to Alexa, and by the way, she's muted, so I don't have to call her lady in a can. so she does not answer back to me. I've done demos and forgot to mute that in our company, and she went off to talk, and I had to pause her and interrupt her. So she's muted until I actually need to interact with her. And by the way, I recommend you doing that at your house with any of those devices. Big Brother is listening, and if there's cameras on there, he's watching. So keep it muted but then you have to get up, right? And the whole reason we had a remote control was so we didn't have to walk to the TV to do something. So catch-22. But anyway, you have policy owner that interacts and asks a question. That goes out into Amazon to AWS AVS, interacts with that. I'll show you how that we set the portal up to connect to our API. That connects there, and then it goes out to the API, calls back to our API. Our API goes back and hits database or data, whatever functionality you have on that back end, and it can turn around and call ESBs or in-service bus or whatever for messaging and bring data back. Brings that data back, bundles it up, sends it back to AVS. Yes, yes, yes. Does everybody hear that? Yes. Your data will go through the cloud, it will go through AVS, and it will go to this device. It's the first question everybody asks. Hey, does that data go through the cloud? Yes, it does. How do you think it made it here? Right? But every time you tap on a browser, what does it do? It goes through the cloud. Every web app you have running goes through the cloud. Okay? It's all secure. But that's one of our biggest questions is, does that go through the cloud? Is that stored anywhere? Well, it passes through, and it's stored if the server was shut down in a matter of a fraction of seconds. There's data on there. They don't store it. They don't keep it. It passes through. So then it goes back to this device. Customer interacts, communicates. So a lot of the thinking is what you learn in this is how do you ask the right questions. So pretty much, who here has kids? Anybody have kids? Okay, so pretend like this is your kid, okay? You have to talk to them in some weird way to get them to answer you the way you want to answer them, and not just in answers that aren't going to make any sense that you can't do anything with. So this is the same way. You have to think about how you word things going out the door. And I'll show you an example, but in a URL, if you're going to speak a URL, I have it in both the written so that you can push it to the show devices, but I also have it in speak, and it's so-and-so, this one is myapp.dot, insurance.com. You word it out because it has to say it. If you just put all the stuff together, she says weird stuff, and nobody understands her. But I love you can do the www dot, she'll do it. And of course, you have the one voice that is here. You can pick different voices. You actually can't pick all the different voices that you heard on the shows the other day. So how does this all start? Well, you have an Amazon developer account. You set up a developer account, and then of course inside that you can do all the development inside Azure that you want to do. I'm specifically talking about top left, which is Amazon Alexa. And I will get into specifics on how that all works. But I wanted to point out one thing. Tomorrow, from 10 to 11 Pacific Standard Time, there is a webinar on designing multimodal skills for Alexa. Now, they're not going to talk about it in .NET like I am. They're going to talk about it using Lambda. But it's using the new beta, the screens and everything, and they switch back and forth between the older versions of the website and the newer version of the website. But if you want and you're interested, that's going to be a pretty good deal. The other thing, all the time, once you sign in, they have a blog. They're really good about updating information. In fact, this came out February 1st talking about the new Alexa Skill Management API and all the command line interfaces and everything else that are available. So really good stuff that's available, and I've got URLs on here. But if you just go to developer.amazon.com, sign in, it's pretty quick. Some of these will actually show up on the banner on the page. So again, I went over this earlier, but the way the interaction works is customer talks to device, device talks to Alexa service. You have skills that are set up. Your skill is configured in Amazon, and that goes out and talks to AWS Lambda. My app is not written in AWS Lambda, but the AVS service is written in AWS Lambda, so you will always use Lambda whether you are writing something else or not. AVS uses that. Then that turns around and makes an HTTP call, and that's all that interaction is a HTTP call with JSON response. Go into your API does whatever it does to go get data, turns around and sends the response back, then turns around and converts it back into the AVS format that the device needs, and then sends it back out. So now, let's go, is anybody, before I go anywhere else, let's see here. Let's go, yeah, we're gonna go right here first. Does anybody have any questions so far? No? Okay. All right, so we're gonna go into, this is inside the developer portal in Azure. And you go under skills, Alexa skill set. And there's all kinds of options here. This is the new interface. You can learn, you can design, you can build. All right, so let's go back here. Okay. Okay, this is the old interface. You'll see you'll switch between the new interface and the old interface. They still haven't fully updated the entire site. A lot of the stuff is here, but when you go into the old interface, you will actually get linked back and forth at times to the new interface. So I've got all these skills, and what you basically have when you develop this stuff is called a skill. It's like an app, but it's called a skill in this system. The one that I'm going to talk about today is called My App. There are different settings that you have to set up in your portal. The skills information is like the name, the basics about whatever your application. That application ID is automatically generated. You do not have to worry about generating that. The name of the app, very important, because that's what's going to show on the phone. That's what's going to show on the device. If you're on a show, that's the name. Like, I can change this and roll it around, but once you build and deploy and actually get out into the real world, then that's really important. The way this works, which is really cool, the way this works right now is I can build an app. I can create a brand new app right now, point it to my API, and go on my phone. And in your phone or your iPad or whatever you have has to interact with the device, okay? You have to have something that can communicate with the device to interact with it, to turn skill sets on and off. When you develop in this, you're gonna have a screen on the skills. It's gonna say your skills, which are only ones that you've created that you can only see. No, it's not available to the public. So like this My App thing is not available to the public. It's only in my development area. So that's the other cool thing is we can, you know, as companies, we can bring these things up and they're fully functioning, working, everything, but they're not available to anybody else until we deploy, check the box, and Amazon says, okay, that's good, and they do all the approvals. It does have the ability to play audio. So all the intents and skill sets that are available just on Alexa itself can also be used in your app. So if you wanted to write an app to play music, you can do that. And all those intents and skills are available in there. You can do video. And then render template, I don't even do anything with rendering templates. So I can't even tell you what that does. So interaction beta model. When you click on this, as you see, it took us to the new view. Well, used to, it just gave you a couple of drop-down windows, and you cut and pasted your intents in there. Now, an intent, as you can see here, there is cancel intent, help intent, non-intent, search intent, stop, yes. And then I have intents that I've created, claim intent, payment, phone number, policy, search. The intent is how, when it comes into, in .NET, when it comes into the controller, it'll come in as an intent. And based on that, you can do a flow or a process or a path to take it to a certain place. There's also a session ID in there, so you know whether they're new or they're coming back. And if they're coming back and they have a session ID, then you've asked a yes or no question, or you've asked something else, then you can follow that flow and you know where they've been or where they're going and what, so you have the ability to keep track of what's going on. And then there's slot types. Slot types are value types. In mine, I'm using Amazon number, and that's the only one I'm using. I do have search values, so in search values is a list. So if you wanted them to specifically have a list of options to match up on, then you would create a slot type, and you can get in. I won't get into a lot of details on that because I'm going to spend more time on the code. But again, that skill set tomorrow, and it's all this is also available on the blog. You can find a lot of this information that's specific to AWS. Now, what does that stuff look like? This is what it looks like. It's just JSON that's got specific values, and this is the way, when I first did it, this is the way I did it. I was cut and pasting this into a couple drop-down boxes. But now, as you add intents and do this, it all creates this on the fly. So this is what's running in AWS. Here's another trick. When you update this, you click Save Model. You're like, okay, I'm good. And then you go back and you try going, and it's like, hey, your model's not out there. You have to click Build Model before. To me, it's frustrating with this new beta because it's like, okay, I've saved it, right? I should be able to go back and immediately use it, but you can't. You have to click on Build Model, and that'll drive you crazy. So remember that. If you're sitting there clicking, this option is not, I can't even, because there's a disable and enable. It's like disable. You can't even enable it unless you built the model. So that actually binds it with your project. But then we can go back. Skill information takes us right back to the old system. Configuration. So configuration, there is AWS if you're going to run it in Lambda on AWS, or you can do HTTPS, and you can put in whatever URL you have an API sitting out at. So you're going to have an API sitting out somewhere. This is where you put it in. You can turn on account linking. Account linking is if you want to add some form of security. So before they can activate not all or a certain portion of your skill set, they can do certain things, like they could search and things like that, and you can make that available. But if you said, hey, before they go do a certain thing, I want to tie it to their account, then you can add security. That can go do LDAP, it can do Google, Facebook, you can do all that authentication. Anything that supports OAuth 2, you can use. And then if you want to ask specific permissions, then this is where you would ask them. And then the app on the phone is where it would verify all this information. Then the next thing is, of course, we talked about security, since your data is passing across. It's going to be all over SSL. When you start, you can do your own self-signed certificate. Since I am hosted on Azure for my API, I get SSL out of the box for free. So I just check the box that says my development endpoint is a subdomain of a domain that has been wildcard certificate from a certificate authority. So that's another reason to play with Amazon, either AWS or Azure, because you get the SSL out of the box and you don't have to. Self-signed certificates are fairly easy. You know, once you've Googled it 50 times because you forget how to go do the cert to build it and how to, you know, sit there and move your mouse enough to get the activity going. But I'm just telling you, if you can go out to Azure, use that, build it up there, because what I'm going to show you is we'll build it in .NET and we're going to develop it and publish it, so I can publish it on the fly. So we do that, and then there's this little thing, which, does anybody even know what this is? Test? Does anybody ever do that with their code? I didn't think so. Okay. This is, if you don't have an Alexa device, an Amazon device, doesn't matter. You can do everything right here. It will talk and speak and everything else. So you can test everything out. So here's the deal. I can go here and I can just say, let's say ask, I'll put phone number. And this is if someone said, some words, then it's going to go out to my site. Now, if it's up and running, it will give me a response. If it's not, which I got to go toggle over, okay, there we go. I just got a response. So this is what you'll see. This is kind of pretty cool because you actually get to see behind the scenes with this without the device. This is the JSON that comes back that is actually sent to that device, and that device knows how to take that right there and turn it into something. So our response, which on the left side, the service request, this is really, really important because as you're developing, if you use this test piece and you want to test something out, you can see even if your server is not ready and it responds with 500 and it's not ready, you at least can see what's sent in that package. So you can see session ID, you can see these things. Now, you can do research and figure out what it's going to look like, but this tool is pretty cool to give you, one of the things I used it for is when they answered a question and I had a response back to them and I wanted more details to stay in that flow, then I came back here, and since it's a text box, I can cut and paste JSON in there. So I can switch over to the JSON tab and say, this is the JSON I'm sending back, and this is what I'm getting back from them. And you can play around with JSON data. So you don't have to do it through the typing. You can actually do it with data back and forth to see where you really want. But the other part about this is one of the biggest things here is user. Like this user ID is in here. So that user ID ties it to their account in your system. So somewhere you have to have their connection for their account in your system. That has to be mapped somewhere in your system. Now, also keep in mind, it's a device sitting in a house. Doesn't have to be one person. There can be multiple people on the device. So different people can actually interact with your services. Based on that, like I could say, this person has 2 policies with us, this person has 1 policy, different policies. So based on their user ID, it actually connects to the different data. So keep in mind that because it's not just one and done, it's multiple people can be using it. And then the intent, I showed you that list of intents that I created. There was a phone number intent. So this one mapped it to the phone number intent. So when that comes in on my back end, it's going to route in, that controller is going to see that it's a phone number intent, and it's going to take it to a certain path to deal with it. So it makes it a little more efficient, so you don't have to just run through all this list of all these things. You can come in and get quicker to where you're going. And on the way out, this is what the content looks like that I sent back. So I'm going to push play, and I'm not sure if my speakers are turned up.
Our call center phone number is 1-800-555-1212. Once again, that is 1-800-555-1212. Would you like more help from my insurance company?
Okay, so like I said, you don't have to have the device. You can do this. I mean, this is like, to me, this is like cool stuff, right? I mean, I was like geeking. I had the device, and I was like, you be quiet. I just want to work on, I mean, this to me was like, this is like so cool. Because I was making her say stupid stuff too, just because I wanted to hear her say stupid stuff, and that's what we do. I never checked in any of that code, by the way, David, so don't worry about that. But if you notice the speech, and here's a couple things. There's an output speech, and then there's a reprompt. What she's going to do, okay, is she's going to ask you a question. That's the output speech, right? And then when you do the output speech, part of that is the output speech is the response, the answer. And then if you want, which that's the way most everybody does it, is here's the response, and then there is a request. Like, here, your phone number is this. Would you like more help in whatever? That's the response. You tag that onto the output speech, so she says it, and then immediately she asks a question. You don't have to do that. You can just say the response. She's going to pause, and then reprompt will be spoken. And reprompt is just like this, it's the request. So I prefer to tell them what they want, ask them again what they want. If they don't answer, there's a short delay, and then ask them again what they want. And then if they don't get that, then it comes back to us saying session canceled, and then we respond, okay, thank you, and we're going to cancel. You can not respond if you want, or you can respond and let them know. So that prompt, that output speech and reprompt is pretty cool how that works. Now SSML is their markup language. If you notice, it says speak, then there's a paragraph wrapped around some text. There's another paragraph, comma, paragraph. It's not HTML, just because you see paragraphs there. It's not pure Oh, yeah, there we go. Yeah. It's not HTML, but it is HTML-ish. It's HTML-like. Of course, you can get all the what's available and everything else. There's one that says say as. So words that may not come out clear, or you may have, you may have a company name that it's hard to say, or like I just got back from Dynatrace. Well, Dynatrace is mostly Austria and all these European people, and even the speakers were having a hard time saying people's names. Well, if you know those names are there, you can actually store that say as content somewhere else. So go get this, but if this happens, I want this name said as a certain way. Now, of course, I don't think you could get away with that on everybody's name, because you would have to have somebody go through the list and figure it out. But when you're asking questions, you want to make sure that it's asked in a proper wording. So that's kind of like when I was talking about talking to the kids. You just got to play this stuff back, and sometimes if you don't put a paragraph around something, that creates a pause, right? So it says this, and then it pauses. So if you don't say that, she can rumble on sometimes, and it probably is speaking about as fast as I am right now, if you don't wrap a pause around it and say, okay, take a breath. Okay, say the next sentence. So it's interesting to think about technology and talking to us, because we expect it to just do it. But I was in conversations with people, and I'm like, okay, what did you say? It's like, I mean, I couldn't even understand what they were saying, and we were talking, and I've been talking, since I was 1 year old, which is almost 50 years. That's a long time. But this technology, new, while it's extremely cool, it still has, we're still working on it. So that's how you can test everything. Of course, if you go to JSON, you can cut and paste requests in. Let's see here. So that's on the test. And then, of course, here's what it looks like on the Echo Show. If I had sent back images or anything like that, you will see that here. The spot, which is the little bitty circle that just has an image on it, you can send back images. You can send back audio. So one of the things in our demo, I don't have it turned on now, but I had an audio file. So when you connected to us, it played the audio file when you open, which is cool, right? But after you hear that like 50 times because you're asking the app a question, you don't want to hear it anymore. Well, there's different kinds of connects. Like I can say, open my app, and that comes in under a, not a request intent, like a welcome intent or something. It comes in on a different intent that takes a different path. Or you can say, ask my app. Well, that goes directly to the specific intents and bypasses that first one. So you can do the sound on the first one, but I promise you, I wouldn't do it very long, because maybe I spend more time saying open this and I get tired of hearing it. Maybe the customers wouldn't do that. But that's where you want to have a beta group and have them test and give you feedback on the way you're asking questions, how things are visually showing up. Keep in mind that there's also a portion of this JSON data that goes back, and it's called the card. What is said here and everything else can also be sent to the device, so you can keep it for logging. So debugging is really cool on this app because it actually tells you on the phone what has happened. So you can check your logging and everything else, but the device will actually tell you when things are logged problems. So there's all kinds of stuff involved in this, and I've got to get to the app because we're having a lot of stuff. Publishing, you pick a category, You push it, and that's how you get found, okay? You can decide how you want to do that. Okay, so I'm going to skip over from this over to Azure real quick. Okay, so just to show you that this is not just me smoke and mirrors. Alexa, ask my app for the address.
Our mailing address is 123 Easy Street, Oklahoma City, Oklahoma, 73114. Once again, that is 123 Easy Street, Oklahoma City, Oklahoma, 73114. Would you like more help from my insurance company?
Cancel.
Canceling the last action per your request. Would you like more help from my insurance company?
No.
Thank you for using my insurance company. Insures your way. Stopping per your request.
Okay, that was real, connected back to the API. I went out to Azure, I stopped my API, okay? This is what happens when you mess up the JSON data going out the door, when your API is down, when you messed any kind of syntax up. This is what Alexa will do. So keep this.
Sorry, I don't know that one.
Yeah, I know you don't. That's why you gotta use the mute button. Okay. Alexa, open my app.
There was a problem with the requested skills response.
So she's very nice. It just says there's a problem, right? How many? We've had those calls, right? How do you troubleshoot that? Good luck, okay? When I was first doing this, I was like, I just changed like 2 lines of code. I didn't do anything. But the JSON data going back, the biggest deal is that speak and the HTML inside there. If you're missing any tags, the web loves you, right? They'll still render your page. She's like, I'm sorry, can't do it. So pay attention to your JSON, your markup. Most of the time, that's where your problem's going to be. So now I'll do this again. Fire it back up. And then when you fire your back up your API, sometimes it takes a little while. So let's see if she responds or she gives us an error. Alexa, open my app. Just trying to connect. Azure, which means I started it, but it's probably not woke up yet. So we're doing that whole wake up thing.
The requested skill took too long to respond.
Okay, but a request came in, which probably woke it up. Alexa, open my app.
Welcome to my insurance company. Insure us your way. You can say, Alexa, ask my app about my policy, and you will hear details about your policy.
Okay, I'm not gonna let her talk anymore because we'll interact with her. But I just want to show.
What would you like assistance with? Policy, claim, account help, phone number or mailing address.
There we go. That was the reprompt. See, because I didn't respond. Push that button to try to cancel her. But so it's kind of interesting because it's going to keep doing and working and things like that. It's really fun. It'll drive you crazy, by the way. But it's fun to do. But in Azure, you get all these app insights and everything else. You can see traffic. You can see the requests coming in. So this is all backed by a database. Okay. I mean, it's real functioning stuff. So let me go right here. Okay. So this is a screen that I built that I can basically monitor my database, the requests coming in, like the requests that we've looked at. This tells us the type. I talked about intents. This tells us the type of intents that are coming in, whether it was new or whether it was the launch request is the one where the welcome is when you say open. Whether it came in with an action no, yes, it was the response. So these are just tools that I wrote myself to make coding in this a little easier. So now let's actually get into code. Okay. So at the basis of this, there is a set of, I have two projects. There's a data project and there's a demo project. I split those up so that my data project was really more dealing with the storage in my database, some of the contract stuff, and then my demo is more geared towards interacting with the user. There are controllers. So the first thing I have is this Alexa controller. There's a lot of code in this. Okay, it's probably the biggest controller you've ever seen. It is an API controller, and it has one devices.alexa.flow, and it passes off the request. So like what I said earlier, if you code this in a very flexible way, then this is the Alexa controller, and I can have a Google controller, and I can have a Siri controller. There's one line, it's devices.flow, and then that code can route wherever to go do the uniqueness of the speech or whatever else is there. So we will go, let's go into that. So then what we have in this code is, this is the basic stuff that you get in that request. Now you can see it in that JSON data that I showed you earlier, but these are the things that are going to come in. Slot lists, whether like action yes or no, that's in the session. So those are custom things that I can create. Some of these are things that are built in. Some of them are things that you can create on your own. And I won't get into extreme details on that, but I can talk to any of you at any time about how this really works and how to deep dive down into it. And then I will be getting some of this bundled up in the more usable, testable code base so that y'all can play around with it. So then there's a handle request that comes in, and this is where the big stuff kind of starts happening. So it's pretty simple. Came in a controller. It has the request that came in. There's 3 types of request types. Based on that, it's going to go split off. And then from there, we get to rolling. There's an include card. What I talked about on that is that card is there. You do not have to send data to a card on the response, because you don't have to you can just deal with this. But if you want to keep track on their phone, cool thing is you can have a response that's spoken, but there may be like a policy or something, like a document or something. Well, you can talk about that document here and say, I've attached it to your device, and it's on this. So then that image or whatever else is actually on their device. So now you're really working between the 2 devices. So you can do some pretty neat stuff. So simple .NET code, verifying whether we're going to send SSML back or not, which really all that does is it wraps it with speak. If you don't wrap it with speak, then you can't put the HTML markup stuff in it. That'll also give you, there's a problem. Alexa will be like, oh, there's a problem with the application. And you can take an hour and a half to figure out that you forgot to wrap it in speak and then feel like an idiot. So I'm just idiot proofing y'all so y'all don't have to act like me, learn some lessons that I had to learn. And then here's another thing that I've done is with a yes or no action, I actually send out to the device and say, okay, yes, I want you to come in this way. No, I want you to come in this way. So as opposed to having to wait till that round trip comes back, then I give it help. So if they say yes or no, then when it comes back in, I know what that yes or no was. So it's kind of like full circle. You can handle that locally with that session and manage that all you want. But on this one, in just getting started, I said, I'm going to tell you what yes or no is, bring it back in, because it all comes back in that JSON payload. But again, that's just the way I design my specific stuff. You can do any of this any way you want. So this goes out, and it does of course, this respond with is just saying, go get whatever that answer is, whether I have to go to the database and get details and bundle the data up and then respond. It does that and send it back. So it's pretty simple in code. It is. Get the request, examine the request. What kind is it? Go get the response, whether it's data from database or whether it's text that's in a case statement or a database or an array. Go grab it, bundle it up, and send it back. So from the functionality, it's pretty simple. One of the tricks to this is this right here. So the Alexa response. And this is what is sent back. So this right here is the response attributes. This took a lot to figure out and learn and make it in .NET so that the JSON looked exactly the way it was supposed to going out the door. So this kind of stuff, I can give you all this kind of stuff because this stuff is, it's a whole lot easier just to cut and paste it and say I'm going to start with it than to try to figure out what the names are and everything else. Because it's nested. There's a lot of nested stuff in here. And then this basically builds out the whole cards, whether you're sending cards and content and everything else. The other part of this is responses. So I use enums to make life a little more easier. And you can have whatever kind of enums you want for whatever application you're doing. Don't have to use enums. This could be go to a database and get IDs from a database and get content from the database, whatever you want. I put these in code because at this point I'm going and getting real live data. And at this point I was just like, I'm going to put it in code. At any point moving forward, this can go to a database and you put a front end on it and then people can change the text, right? And then we're not changing text in code. So I don't recommend sticking with this, like moving forward production-wise, but this is just how it is. So all these enums are set up, and then this is kind of what the responses look like. This first one is the welcome. So when I say open my app, it's going to respond with this string format. Really good, lovely, but as we know, when you see that first thing, 12 and 13, that should be like, holy crap, it's a lot of like variables to replace and keep track of, which is also part of the problem when you do that many variables and you go to change one in the middle and you accidentally delete one of them, and then, yes, and it's like, then she's like saying stuff and you're like, what the heck? That doesn't make any sense. Did you lose your mind? You know, it's like all the variables messed up. So it's like, then you got to go figure that out. But source code, checking in and out, see what the diffs are, make your life a whole lot easier if you start that from the beginning. But as you can see, this is wrapped with text, like paragraphed. I think I have, I don't remember if I still have any say as's in here. But this is how that return goes. And then all these are just the paragraphs, and right before I send it out the door, I wrap it in the speak. Because I was putting it in here at different times, and that's when I was like, she's like, your app has a problem. I was like, okay. So I finally moved it to a single point. But you can, and like I'm reusing variables. So part of this is on a session ended. It says respond with speech response, thank you, and then company with slogan. All this is just literally whatever you want to set up, however you want to make it work, okay? All right. So this is all there. This is all set up. Let's go in. I'm going to, okay, I've got like 5 minutes. I'm going to go in. I'm going to talk to her, and then I'm going to change something. We'll see it change. Alexa, ask my app.
Sorry, I don't know that.
Well, then let me talk. Alexa, ask my app for their address.
Welcome to my insurance company. Insure us your
You have to
life.
talk faster than
You can say, Alexa, ask my app about my policy.
Okay.
and you will hear details about your policy. Or say, Alexa, ask my app about my claim, and you will hear details about your claim. Or say, Alexa,
Okay,
ask my app
so
for
right
your
now,
address or phone
it's
number.
reading this paragraph.
You can also say, Alexa, stop, or Alexa, cancel. What would you like assistance with? Policy, claim, account help, phone number or mailing address.
Cancel. Alexa, cancel. Okay. All right. So I'm going to change this. And this is really cool because I do this live. And you know how well that works. Okay, somebody give me a name. Here we go. Okay. Save this. And yes, which we can't do inside my office. So what we're fixing to do is push code live out to Azure. It's going to get out there. It's going to get updated, hopefully. And then when next time we talk to this, it's going to say Techlahoma and coding your way when it tags it at the end. Oh, that's okay. Again, this is a revocation on certificate, Visual Studio. Get used to it. Just got to click OK. I've saved it 100 times, and every time I still have to do it again. All right, boom. It's out there. It's coming up. And this actually controls my little front end also. So it's putting it out there, waking it up. Now, I did not change the name of the app, right? It still says my app. But you will hear the company and the tagline change because we did that. But I'm just showing you can literally make changes and get everything else. Now, just for grand's sake, I'm clicking wake up because I want to make sure it's okay. So let's do phone number. Alexa, ask my app for their phone number.
Our call center phone number is 1-800-555-1212. Once again, that is 1-800-555-1212. Would you like more help from Techlahoma?
No.
Thank you for using Techlahoma. Coding your way. Stopping for your request.
So, live deployment, okay? Only stupid developers do that because it never works, right? I've done it before in the middle of a demo and I was clicking around, and the other thing I can control is the data. Like I can change how many policies and this and that. If you click them out of order, it's just SQL script that's going and adding stuff, and I was like, okay, hold on, clear my database, let me start over. That's that. I'm Gary Carr. I'll stick around, answer any questions, and I will make this stuff available so y'all can get it, and I can help with the .NET. Again, you don't have to do it in .NET. You can do it in Lambda, which I recommend learning Lambda and playing with that also. That's where their skill set's going. You can literally use Node.js, Python.
Use C#.
This is C#, yeah.
But you use C# at Lambda.
Yeah, now, yeah. So, so you can, but then you're hosting everything in AWS, which is still not a problem, but I'm complex and I wanted multi-cloud and, just to prove that this stuff could be done. So thank you very much. If you have questions, I'll answer them. And she's supposed to be walking. She told me when she gets close, then I'm supposed to finishing up.
I know, is Alexa prompt only? So can it send, so like on a bot, you can have it send you a message when a certain event happens. Can you do that with Alexa?
So the event-driven stuff is new. Oh, yes, exactly. Thank you for pointing that out. The question is Alexa prompt only or event-driven? From what I understand, the event-driven part is functioning, but I don't know how well it is that it interacts with it. So I can't give you all the details other than the blog that I referred you to earlier. That's the best place to go get up-to-date information on what's going on. Yes?
The sessions, are they only closed for the user prompt, or is there like some sort of timeout that happens that would close your session?
There is a timeout, and the question was, with the session, is there a timeout, or does it close out only with user? So both. A user can say cancel, stop, and that's a stop and cancel intent that comes back in, and then you can decide, like, my response to a stop or cancel intent is thank you for using whatever in our tagline, because it's more cordial than just nothing, no response at all. You don't have to respond. If a session's there, they're walking away anyway, right? So I'm probably catching them going, okay, and they're walking away. Now, the other thing I was going to show you all is Super Bowl, because one of my demos was in the Super Bowl. You basically could, in the middle of a commercial, a bad commercial that you didn't like, you could say, Alexa, check on my claim. She would go out and check on your claim and say, hey, there's a check in the mail or whatever else. And you'd be like, awesome. You didn't have to get up. You can still drink and eat. You could still watch the game. You did it during a commercial. You didn't have to go log into your computer. Just showing some of the cool stuff that we can do now. The other one is you can talk to the TV. If you got Fire TV, and you can interact with the TV. You don't want to do that when everybody else is watching the game now, because it's like messed up. So the other part of your answer to your question is the session automatically ends very quickly if you do not respond. So if you do not respond within 2 or 3 seconds, if you send a reprompt, she will reprompt. Within 2 or 3 seconds after that, she's going to finish. And if you haven't responded to that, it sends a session ended. So you get the stop intent, and it says, okay, all right, they're done. And then you can respond. And my response is a cordial response where you don't have to have one at all. So anybody else? Questions? Yes? No. So the question is, when you deal with multiple people on a device, multiple users on a device, no. The only way that we know that they're different, we can't interpret voices. That's a perfect question, because someone asked me that. I was like, just like on the web, cannot tell you if Gary Carr is sitting at that computer or typing on that computer or speaking to that device or whatever. No different. That's what everybody's, worried about these devices. I'm like, it is a browser. It's a verbal browser. It's no different than this. There's authentication. There's SSL. Same security that we wrap around this. So the difference is each user has their own ID in Amazon. That ID comes in. That's the ID that you link up. So when they do account linking, they're doing it through your phone, right? So their user ID is here on their device, and with account linking turned on, they have to account link in their phone. So whatever your OAuth 2 thing is that you say, log into my system, oh, okay, do you give, does Facebook give you permission to use this app or whatever? It's the same way. You give them, you've linked them up, now that user is connected to you. That's how you don't have to do that, they do that. Yes?
Does that user ID carry over among multiple devices, like that, your TV?
The user ID is the same. The device, so the question is, does the user ID carry over on multiple devices? User ID, yes, it's the same user ID inside Amazon. The device ID is different. So we can see the different devices that they're coming from. But the user ID will be the same. Yes. Questions? David Roberts, any questions? No? Okay. All right, well, thank you very much. And like I said, I'll stick around and do whatever I can do.